for joining. I'm Danny, happy to be back in New York. So welcome to 10 Myths about testing, or how it was in the agenda, 10 things about testing that you might have known earlier, or in various variations of this title. But I think you get what this is about. Few introduction words, because I'm not from New York, I'm from Berlin, Germany. Happy to be back here. I did my first proper programming job in 1998, so it's been a while. Was C++ back then, did like low-level protocol things, writing Java and embedded Finters feature phones before like Android was long there, then the Blackberries, and then Blackberry died, so I had to do something else. Android came along, so that was my career. Right now, 5 years already at SoundCloud, so you might have heard them, biggest audio catalog in the world. I think the only streaming platform that is profitable, so cool place to work for sure. And we have an office here in New York too. I found out this slide, and I sometimes use it when I talk about testing, which sometimes happens. This is the first public talk I gave about testing, 2008, in BlackBerry Developer Conference, Santa Clara. It was about unit testing already. That's like a long time ago. The last time I was here in New York, I realized I also talked about unit testing. It was JUnit 5. It was in 2018. So yeah, it was time that I come again and talk about testing one more time. So the idea of this talk came a bit when I realized there were certain things in the past that I believed in, that I would fight for, that I would argue for about testing. At a certain point, I changed a bit my mind, I learned something more, or saw a different point. But then a new Danny came around, a colleague or someone else, who basically had the same opinions that I had before, and I had to convince him, or them. Yeah, this happened a couple of times over time. So I realized maybe collect these thoughts and bring my learning, and maybe someone can learn something from it. And maybe we can argue after this talk if you disagree with some of them. So what is a myth? That's why I changed it to 10 myths. According to Wikipedia, it's a widely held but false belief or idea. So I found like 10 things that some people think are true about testing that maybe are more like a false belief. Just to get things right, I'm not advocating against not testing. Actually, I'm taking Michael Feathers. Code for a test is bad code. And it doesn't matter how well written it is. It doesn't matter how pretty, object-oriented, well-encapsulated it is. According to Michael Feathers, code for a test is bad code. Very rough statement, but I still believe that tests are very valuable. Although there seems to be a trend of people, that folks trying to give up on testing, completely removing all their tests and say testing is a bad thing, they cost you too much time, they're not valuable. And one reason, or some of the reasons are in here, these are the myths, because we also went a bit to the wrong path, similar to with clean architecture, where in the beginning there was no architecture, and main activities, we had 15,000 lines of code. And then we had, I don't know, 15,000 layers, it feels like. So maybe testing we had something similar. So the myth that I want to show you, it's not a very simple one, but one I believed in, that any change should lead to a failing test. When I was very young and started unit testing, I remember changing something, and I was very proud. Oh my God, yeah, my unit test get right. It makes sense, right? I changed something, something needs to fail. Yes or no? So I found a nice quote here. 90% of the time, unit tests fail not because of a bug, but because of changes in implementation details. New dependencies, refactoring, bugs in the test itself, or just incorrect mock setup. So often, they prevent us from introducing bugs, which is the whole idea, but from introducing change. And we've all had this, right? It's so hard to change something, but the test's failing, but not for the reason. There was no bug there. Let's remind ourselves about one thing. Martin Fowler always keeps saying it. Refactoring means changing the internal structure of your code without changing the externally visible behavior. Or to quote Uncle Bob, what your software does is stable, how it does this is unstable. So, and the whole idea of unit tests, and one of the main purposes, is to allow refactoring. If we can't refactor because of unit test, there's something wrong with our tests. Let me show you an example that I had a couple of years ago in the company before I joined SoundCloud. I wrote this app because I was alone, very TDD-driven. That was a super nice experience. And I ended up with a test like this. It was like a view model test, tested the view model. And when I started, there was no repository and API, and everything evolved during refactoring. But I kept this one test. So the test tested multiple things here. So I didn't do a traditional test in isolation here, as it was supposed to be. But for me, why should I change the test? Just because I expected a repository here. So I had this. And then a colleague came, or joined the project, and he was very eager to try out Redux. And then he said, Danny, can we try Redux in this project? And I said, you know, yes, I like the idea, but maybe not now. We have to have a release date, right? And I wasn't clear enough, I think, what I wanted to say, because I came on Monday to work, and he introduced Redux. He said, don't worry, I did it on a weekend. The interesting thing is that the tests still run. We had to update the constructor a bit for some new parameters, but the tests were still green. Why? Because the behavior of the view model didn't change, but the view model exposed. It didn't matter what is behind that. That was like one of the revelations back then. This wouldn't have worked if you have something like this. You would have changed probably all of it. And if you now think about the Redux one, probably would test like this for like side effects and I don't know. There's something wrong because what you're basically doing is this, and you might have seen this meme. So all the unit tests are passing, but maybe you missed the whole point of what you were supposed to do. And I know what some of you might think now, Danny, this is not a unit, or that's a unit test, which is myth number 2. They're very connected. So let's talk about this. And as you see, I use the whole presentation, a lot of quotes. So I'm trying to give you my learnings, but in other people's words that are much more popular than I am, much more known. So if you ask 3 different people what a unit means in the context of unit test, you'll probably receive 4 different answers, Martin Fowler said. Very true. This is one of the things I had like a while ago discovered, and there's like a Medium post out there also. I wrote about it. This is why this myth came over time. Some of the things I put in talks, some in blog posts. So let's dig into this. For this one, nice one. If you read TDD by example, so the famous book by Ken Beck, it became very apparent that unit is a module within an application. So unit does not denote an element of structure, but an element of behavior. So it's very similar to what we just talked about. So the definition of unit tests should be, unit tests are fast executable specifications of a required behavior. And I like that, so we should think of units like this. It's not about function. There's a lot of talks out there, and this is like years ago, before we even thought about Android about it, that it's a bit hard to tell when we changed the definition, when we thought it's a class, an isolation, and a function. But back in the day before, it was modules. It was more like a larger thing. It always was like this. And the word unit test in TDD by example happens one time in the whole book. So maybe we should just give up the name, some suggested. Just call them developer tests. That's what Ken Beck is doing. So if you have something like this in your test, that's like part of the Android Auto test that I'm having. I'm creating a lot of classes. These are the real instances. It looks a bit weird, but there's no mocks there. I just pass the real thing and testing multiple things at the same time because they're actually derived over time. There's nothing wrong with that. And they're very fast, actually. They're still unit tests for me. Which brings us to a related one when we're seeing these huge constructors. We've all been told to write testable code for years, right? It's the one thing most of us heard this term. Let's look into this a bit, because this writing testable code is, I think, one of the big reasons why some people give up on tests nowadays. Because writing testable code at some point became worse than writing the non-testable code. So let's look what other people say. So if you design first and foremost for testability, you get what you pay for, testable code. More often than not, this design will be completely disconnected from the project's business domain, its requirements. It will resemble an enormous object graph full of accidental complexities, but it will be testable. Testable by tests that are drowning in mocks and will fail altogether after changing a single bit in the implementation. That's what they call test-induced damage. And it's really depicted in the HH post, the TDD is dead. That's a post on the HH. It's the guy that wrote Ruby on Rails, where he basically declared TDD was like one of the worst things in the industry. Some people agree. And he introduced this test-induced design damage. So because we want to write testable, we completely mess up the design of our applications. And this is not only related to Android. This is like out in the world. We see it everywhere. And there were a lot of good discussions about this. And we've seen this. This is something I brought out from our code base. I don't have to dig deep to find constructors like this. So we really think that this is good code because it's testable. I don't know, complex dozens of completely random things that we're passing in, but hey, it's testable. I gave a good example a couple of years ago in this blog post here about the art of construction. And it's a bit related to two other things that we should talk about. One is dependency injection, because we can forget about it because the constructors are filled automatically. And the other one is mocks. And Ash's favorite topic, mocks are helpful. This is something where it's definitely not controversial nowadays anymore, because a lot of people saying that mocks are actually harmful. So we are using mocks every day, right? We are mocking everything. It doesn't matter if it's Mockito or some Kotlin-based ones. But we are starting to question ourselves, maybe we went a bit wrong. So I found this nice one here, that the real reason that so many developers are using dependency injection is to facilitate unit tests using mock objects. I mean, the last when Kotlin came up and Coin, it was always, do we actually need dependency injection, right? These containers, these libraries. No, but it's so easy, right? Let's use them. But yeah, they're all very connected. Testable code, DI, mocks, what we lost on the way. Uncle Bob says, the need to mock every class interaction forces an explosion of polymorphic interfaces. A lot of extra interfaces, interface classes. This is over-abstraction and the dreaded design damage. So this was the response to the post from DHH. It doesn't see the problem in TDD, but in this testable code that is drowning in mocks. And we've all been there, right? To mock, we have to create an interface, and then we get useless interfaces. And then at some point, realize, yeah, we have one implementation for each interface, so maybe let's mock the class directly, and then completely forgot about the whole idea of dependency inversion. But the mocking framework supports it, so why not mock the class, right? And have like a constructor with 30 parameters. So when you mock too much, according to Uncle Bob, you became slow. Mockito is slow, by the way, much slower than without reflection. Fragile, because they fail all the time, and very complicated test. And you damage the design of your application. So by making something testable, we damage the application. Thanks to mocking. Or some people say, if you mock, are you even testing? Do you really believe that this is testing? I don't know. It seems like we took the wrong road at some point. So what are reasons to mock? Let's be a bit more pragmatic. Ian Cooper, who put some amazing talks that you can find, I'll mention it later. You should mock to allow your test to run faster and independently, not to isolate the thing on the mock. What we are doing is we're isolating one class to the other, right? This unit idea from the beginning. But it's not the idea to use mocking. Make it faster by mocking your database. That's a valid reason to do it. Or independently, but not class it from each other. Uncle Bob gives a tip, mock across architectural boundaries, not within those boundaries. Write your own mocks, your stubs, your fakes, right? At least you're getting out of these mocking frameworks. Yeah, so you're reducing the use of mocking frameworks. So I'm looking for example, and just like I know yesterday was this thing, there was a token provider in the code base, and they're setting up this as a stub, it's just like an anonymous implementation, right? This is not more code than setting up the Mockito. But it's faster and more valuable, and also these two methods are connected already, so there's always a problem that you have in mocking frameworks. Like, think about a list, right? If I call is empty or size equals 0, doesn't matter, but in your mock setup it does, but for the behavior not. And if you have some of this, by the way, you can move it out. So I looked at the code and optimized it. And the most important thing, if you take one thing out of this, please never mock data classes. We had just a discussion about it. Some of us saw this in code bases, like, I don't know, why would you ever do that? Why would you try to mock a data class? But I've seen people doing this, and then they're using a setup around it. It's a data class, just fill it with data. And if it's complicated, write fixtures or something like this that generates them. We have tons of fixtures for all the things that we need in the SoundCloud code base. No one would have the idea to mock a data class. There's definitely something wrong when you go down this path. So try to hold. So this was a lot of kind of very connected things, right? Mocking, DI, testable code. So I'll leave it here for a moment to sink in. Let's go to a different one. Definitely believed in this for a while. Test coverage is a very useful tool. I remember my colleague sent me the next slide, and I definitely saw myself here. So when you ask what's a huge test coverage, so the junior would say, oh, yeah, sorry, it's just like 35%. I'm working on it. And then mid-level, hey, I'm already 95%. I'm getting there, I'm getting there. And then as a senior, man, I don't even know where to find this number. Definitely see myself there. Remember when I started with the eBay app, there was no test. I used the first unit test in the Android app, but I was so proud of myself. Look at the Sonar statistics, comparing it every day with the back end. It was growing and growing. I added rules, so code coverage can never go down on a pull request. And then I need a hotfix, and then, oh fuck, then you're cheating a little bit here. And this is how it starts. I think most of us have been there. So what's code coverage? I think it's from Martin Fowler. It's a very useful tool for finding untested part of a code base. It will tell you what is not tested, but it's nothing more and nothing less. It cannot tell you what's tested, even worse. So monitoring or enforcing code coverage may do more harm than good. It incentivizes writing junk tests, and even worse, creates a false picture of your actual test coverage. So, and you might have seen this as well, right? You can reach coverage without having a single assert. It's a complete false picture. I've seen these boards. Everything is always green, great, but underneath actually you forgot to test the right thing. My boss gave me this one. Measuring code coverage is like judging a song by how many notes it has. You can do that, but you're probably missing the whole point. I found a similar one. By writing this talk, I remind myself, I had to think about something. I think it was 2007 or so. This PDF came out. There was a guy called Alberto Savoia, and he published a thing called The Way of Testivus. It's ancient wisdoms from the Middle East, from a startup back in the days. It's very, very fun to read. I'll show you one of them. The pupil went to the master and said, "All my tests pass all the time. Don't I deserve a raise?" The master slapped the pupil and replied, "If all your tests pass all the time, you need to write better tests." I like this, and this reminded me a bit of like, hey, this false picture. Yeah, everything is green, but maybe you don't test anything. The whole thing continued. With a red cheek, the pupil went to HR to complain, but that's another story. So check out The Way of Testivus. It's a bit older. The PDF is free. You still find it out there. It's always interesting read. Cool. And Android, I mean, I don't know. I have no idea where code coverage is. We don't measure it anywhere. I probably saw it in Android Studio every once in a while when I click the wrong button. But yeah, it can be useful when you come to a project to see what's tested, but don't enforce it. Which brings us to let's completely turn our attention to another area. Flaky tests, and we all love them. I took a sticker earlier, but I think I forgot them. There's some from one of the sponsors out there. There was a nice one about flaky tests. So we all know flaky tests. And all the studies show this. So there's a study that showed half of developers experience flaky tests every month. Sounds like definitely true. Another one said 41% attested Google that passed or failed once or more were flaky. Same number 26 at Microsoft. And these are teams, these are huge companies with huge teams. They have flaky tests all the time. When you talk to them, they run for hours, and still there are some things that always be flaky. Or someone posted this, I think, 2 weeks ago. Some iOS framework from Google. Hey, yeah, so there's something. It will always be a bit flaky here. So we're trying, but that's a bit of a problem. And we will have it everywhere. So as the number of tests grows statistically, so will the number of flakes. It's very simple, right? If each test has just a 0.1% of failing when it should not, and you run 10,000 tests per day, which is not much in a larger team with CI, you will have 10 flakes per day. And we all have this, right? I mean, we went from Robotium to Espresso. Then we went to idling resource monitors, and we did all the back practices, mock the network, step out a lot of things. But at some point, we start using Gradle plugins that start restarting a test if it gets red. So maybe it's flakiness, right? We didn't even thought that we're doing something wrong there. So like this one, fighting flakiness can sometimes feel like trying to fight entropy. You know it's a losing battle. And a battle you must engage in again and again and again. And then you feel like this one. And it gets even worse. So it's like you're completely demotivated. If the test flakiness continues to grow, you will experience something much worse than lost productivity, a lessened confidence in the tests. And when I just mentioned this Gradle plugin that most of us using, and one kind of the other, really test gets red, and we just run it again, and hopefully it's green, and think it's probably correct. I don't know, I think there's something wrong there when you think about it. And at some point, yeah, you lose your trust. It's probably just flaky. We've all been there, right? A lot of things I ignore. It's just a flaky test. It always fails. Maybe it actually fails now for a reason. So at SoundCloud, so for years, we tried to follow all the best practices. We had a build sheriff. If something is red, immediately jumps on it. He checks it. He once it's flaky. He will try to fix it. If not, he will ignore it. We will write a ticket. We look at it every week as a team. We prioritize. We try to fix, move, and all the things that I showed, like moving to espresso, adding result monitors. In the end, we all know it will be a wait plus 3 seconds or something. Works most of the time. Just recently, we dropped all our tests. All our UI tests are gone. iOS did it first, we followed. There's no flaky tests anymore. It's not what I recommend you to do, but, and we still have some running nightly, but we want to have something else there, and I'll mention this later. But yeah, we still write a lot of tests, a lot of unit tests, also on electric testing kind of things. But we gave out trying to fix, and the cost of years of life, and what's the value. And we talk about the value also a bit later. Because it's related to, we have to test all the things, right? Especially earlier when I started unit testing, yeah, all the edge cases from the max int to the min int, and you have to test everything, right? Every case you have to test. So let's think about this. Again, DHH here, which I don't like him, but there was a lot of good quotes from him. So the problem of calling over testing is a hard one. Because there's no catchy phrase, there's no sexy term like test first, red, green, but over testing exists. You can over test. So let's ask yourself, what's the cost to prevent a bug? So how many thousand lines of code of validation is it worth to catch a one-time accident? Our iOS team had this. There was one test where they keep investing a lot. They always had to update it. And then they asked themselves, when was the last time we catch the bug of this one? That was 5 years ago. But all the time they had to update this test. I think there's something wrong with this test. And we can look in how you can measure this a bit. One tip is, in software testing, there's this Pareto principle I learned. We kind of summarize it, 80% of all bugs will happen in 20% of the modules. And you can also translate this in a lot of things. Think about UX. You will find 80% of your usability issues by just giving it to someone and let them play. But you can also go to an agency, spend $100,000, they do eye tracking, and everything, come back with a report. It's more than 80%, but the 80% you can fix easier. So maybe focus on the 80% and not trying, the additional 20% cost you more, we know that. So think about this a bit. What's actually worth testing and what's the price? And this comes with a second one, so they're related, so it's kind of the same thing. We have the testing pyramid. And for a long time, I thought that's true. Testing the same thing on different layers is totally fine. Because I always saw the testing pyramid as safety nets, and just like the next net, and just check there again. Find some nice quotes here. Again, Martin Fowler speaking. While your gut feeling might say that there's no such thing as too many tests, let me assure you there is. Every single test in your test suite is additional baggage and does not come for free. Writing and maintaining tests take time. Reading and understanding other people's tests take time. And of course, running tests take time. I mean, how long are we waiting on the CI pipelines to run usually until you can merge? Definitely know this one. As with production code, you should strive for simplicity and avoid duplication. We always forget this. We always forget that test code needs to be cleaned as well. And that means also don't repeat yourself. So Martin Fowler gives some tips. He replaces all higher level tests, not all, he replaces higher level tests with lower level tests. By the way, one reason why I could remove a lot of espresso tests, because I trust the lower level test more. He deletes a higher level test that is already covered on a lower level. So try to push them down the pyramid and delete if it's already tested. And there's no reason to waste precious time on a test that is keys to provide value. How many of us, we often forget about that. It's okay to delete the test. We keep it there. Probably the feature flag is not enabled anymore for years, but we have the test. I mean, it's nice to have it. What does it cost, right? Still comes with a cost. It's fine to delete them. So last time I wrote espresso test, even before we deleted them, was it years ago? I've been there 5 years now. I wrote a lot of tests. I write tests every day. But an espresso test was like probably 4 years ago. I try to push them down. And so far, I don't know, the code I'm writing, I can usually test them on those levels, which is good. So think about these over-testing and testing on all layers brings us to, we have to automate all the things, right? Some companies even have teams who like trying to automate all things. We're a developer, we want to automate things. Why would we do something manual? There's a simple rule here that I learned. You should automate 100% of the tests that should be automated. I like that. But you can keep something in mind that Alan gives us here. So ideally, it should be like this. You invest into writing tests, you automate something, a use case, a test case. At some point, there's a break even. You get value out of it. You don't have to invest anymore, and maybe it fails, and it catches a nice bug. But we've all seen these kind of things. There's also the flaky ones. I was like, you keep investing. This is what our iOS team said in some of the tests. Like, man, you hardly get it even running, right? It definitely never failed. So, although we are engineers, maybe we should rethink a bit this need for automating 100%. I want to point out to this really good talk from Ben Cadell, the guy here, or his mascot. This talk shows a ton of tools, sets that become of Android Studio, and they just make your life easier. So when I said iOS deleted all the automation tests, does not mean they don't test anymore. They have a QA engineer who's an engineer, part of the team, and he automated a ton of things. Ben showed how he can do it in Android. It's like a small script to this login. It's not a espresso test, but using ADB tools to capture the screen, to find something, and he combines like grep and set and ADB, and does amazing things. And the nice thing is, you semi-automate here with certain flows that you can't fully automate, but you're staying in front of the screen, and you see if something is wrong, and then you just restarted it. Instead of like trying on CI to run it 5 times, you realize, oh, there was a real failure. So sometimes actually going a step back is easier. And amazing stuff here. Thanks, Ben. So one of the things, one of the main things that we just talked about is tests take time, right? You have to invest time. That's why people don't like them. But thanks God, we live in an age of generated AI. So the idea of generating your tests came back the last 2 years since ChatGPT. So I guess we have to look into this. And a lot of people did, so that's not only me. Although I have Gemini enabled in Android Studio and playing with it. Most of the time it's suggesting me things that don't exist. So let's start the first idea. Let's generate a test from the code. So we take the code and let Gemini or ChatGPT build all the UI tests, the unit test. Sounds cool, right? And this guy who wrote this way of test views, the way I found this back then was that he had a plugin, I think from Eclipse back then, that generates code. That was, we're talking, I think, 2007. 2007. And they put it in an open variation, JUnit Factory it was called. And back then I was like, mind-blowing for me. I take my class, I upload it, and download tests. I mean, didn't have all the context, but for me it was amazing. All the edge cases, all the, max int and the random values was exactly what I needed. It wasn't as good as generative AI, but this approach was there before. People tried it. By using these, keep one thing in mind. The test that you will write now, or that someone will write, will tend to establish and support the existing reality you've created. So what if the string transformation is wrong and wasn't the programmer's intent? We'll never know, because you took the code and let someone else write the test for it. The code now documented your behavior, but maybe the behavior was wrong in the first place. You don't have to do TDD. I write like most of the time not TDD, but I write my tests right after the written code, and then when something gets red, it should be green. Wait, there's something wrong. And every once in a while, your code is wrong. You will never know because ChatGPT can't tell you. Probably can't tell you. And there's another thing. You should usually keep your tests clean and refactor them. Uncle Bob says, if you don't involve the test and the code in opposite directions, so here's the idea of the code gets more specific or the test gets more generic. So if you don't treat test as part of your system, if you don't think about decoupling, separation, isolation, you damage your design. If you just take something ready and just generate tests, there's no refactoring happening. There will be a lot of duplications. So that's a good one. So maybe let's change a little bit, not upload the code, But how about we write some bullet points of the behavior and generate then the tests out of it, before we maybe even write the code? This one's valid, and people tried it. So someone says the whole idea of TDD was to use tests as executable specifications. You can run them, written in a precise language, in a programming language, instead of the old design documents written in natural languages. Applying now AI to software development will result in code that is impossible to maintain and requires from rewriting from scratch, just like the old days. You generate something, and probably if it fails, next time you generate it again, is there really value? Also reminded me of something older, it's DHH again, when he says, don't use Cucumber unless you live in the magic kingdom of non-programmers writing tests, and send me a bottle of fairy dust if you're there. Maybe most of you don't know Cucumber was a framework, or is a framework, it also exists for Android, where you write tests in natural language, and then underneath some other frameworks and so. Yeah, now you generate them, so is it really better? I don't know, it reminded me of this one. And I remember when I quoted this a couple of days ago, someone said, yes, we use Cucumber on Android, it's the worst thing ever. And yeah, I've been there. So let's keep one thing in mind. What is a good test? When you can swap up the whole implementation underneath and keep the tests. That is valuable tests. There was this discussion a couple of years ago between, I don't know, one of these gurus, Fowler and Bob and co. If you have to lose one, you have two disks, the test and implementation, and you have to lose one. Which one do you want to lose? And they agreed. If the tests are good, I want to lose the implementation. Because the other one you can never recreate. I mean, you can generate them with AI, but not sure if it's any good. So which keep us, okay, we still want to use AI, maybe as a TDD buddy. So like in pair programming, you sit there, one writes the test, one writes implementation. So think it the other way around. Maybe that's cool. So maybe I can write a test and AI writes implementation. People tried that. So they said, you must specify your requirements very precisely. Otherwise, it will make assumptions. Makes sense? And be aware, never use code without fully understanding it. There's a nice talk from Matthias Geisler at droidcon Berlin. He tried it, and he also looked into people who tried it. And he said, yeah, sometimes it's code that looks correct, but it's actually wrong. It's just generative AI. And he found this nice, it's called the Git Clean white paper, where they exactly tried this approach. And they came up with definitely an increase in copy-pasted code. It's no surprise, ChatGPT, I mean, it's like taking things from Stack Overflow and putting in your code base. And an increase in code churn. So the reverted lines afterwards increased. So overall, they saw a decrease in software quality. So like in general, using AI, the same they see so far in using AI as a TDD body. There's things where I can help, all these studies say. Can help you find unspecified part of your tests, things that you missed. You can generate lots of input for all your edge cases. You know, don't mock the data classes, but if you have these fixtures, you can now tell AI, please generate me all these instances, a lot of random values. So that's a valid way to, so use it as a tool, or not to replace part of implementation. So I have one more I want to mention, because we talked already about the testing pyramid. And it's like the base for everything that we're doing. So remember, the testing pyramid is the original one. Is you have unit tests on the bottom, they're very fast, you have a lot of them. And then you have integration tests, and then some UI tests. And you have a few, but they're very slow. And I think it's still valid. Especially in those cases where you have like the inverted pyramid, like the ice cream cone. So we have hardly any unit tests, a lot of UI tests, they run forever. This is definitely wrong. So here the pyramid is good. But some people started questioning the pyramid a bit. So Fowler himself says, unfortunately, the concept falls a little short if you take a closer look. From a modern point of view, it seems oversimplistic and even misleading. Some other people say, maybe the testing pyramid outlives its usefulness. So why? What if not all unit tests are local and not all end tests run on the device? Things changed. Technology advanced. Just some random things that I came up with. Electric. I mean, it used to be something to enable unit tests at all for JUnit. I remember like one of my first talk was about electric. And then a couple of years I said, please don't use electric because it increases the flakiness, because people wrote like kind of espresso-like tests. So they didn't treat as unit tests. electric was always slow. But then it appeared as a replacement to espresso, so moving them down the pyramid. This is nice, right? I write a lot of V-model tests of espresso for electric. That's super cool. But what are these? Where in the pyramid do they live, right? Mocking frameworks make your whole thing slow. Think about this. Is this still unit test? I mean, it's a bit questionable, but power of the cloud I mentioned. At some point we realized when we parallelized our CI pipeline to be faster that our unit tests run longer than our espresso tests. I mean, of course, there are much, much more, but our espresso tests were parallelized in the Firebase testing cloud. We're super fast. Well, we couldn't parallelize back then as much as our unit test. This was like, fuck, there's something wrong here. They should be faster. And then we realized there's a lot of back practices where we tried and then stumbled upon. So when it comes to speed, there's the execution speed of the test itself. How long does it run? There's the build speed. How long do we compile? And then there's the network in between in the CIO. Why is it important? So we tried to follow this best practice for a while, that you have separate sample applications for certain features. So you build separate APKs and only test these. It's very isolated. You have to build the whole application. What we realized at first, building all these APK takes longer than the original build. And transferring these APK to Firebase testing lab took much longer than the execution speed of the original one. So actually made it worse by following these best practices. It was like a revelation. Oh, fuck. So just keep thinking, what's your environment here? What's the price? I like this one, actually. I never thought about it. In the Android documentary we were testing, they completely have a different angle. They don't even think about the pyramid. They say, how about, put it in a different dimension. Your functional test, what does the app do? It could be a unit test. Your performance test, how quickly and efficient is it? Accessibility testing, and there's compatibility testing. And all of these you can do with different tools. And maybe this is a way to group your testing. Or at least to have like a different angle on your pyramid. I like this a lot. So, what are the things we talked about? Any change should lead to a failing test. Probably not. Yes, there's then probably not a unit, but maybe let's drop about unit test. Let's not think about class and isolation. Write testable code. Let's do not do test-induced damage. Mocks are helpful. Maybe let's try to at least use mocks less. Test coverage can be useful, can be very misleading. Flaky tests can be fixed. Sometimes they can't. They will always be flaky, some of them. Test all the things and all the layers. Maybe not. You don't have to automate all the things, even with developers. Generate your tests is a promising approach, but also not a new approach. So maybe be very careful and never adopt code without checking it. Follow the testing pyramid. Let's give it some new angles. So what can we change? Write tests that help refactoring. That's the main part. It doesn't matter how you call them. Test behavior, not structure. Then you can refactor. Reduce the user mocks and try to reduce duplications in tests. And in the end, look about the effort versus the gain of a test, of the infrastructure you're running them. And just be a bit more pragmatic. We became so dogmatic about like telling everyone how to write tests that I think we scared some people, and people gave up on testing altogether. But go with the Beyonce rule. Google engineering team posted a blog post. If you like it, you should put a test on it. And of course, in a perfect TDD world, untested code doesn't exist in the first place, so TDD is still a nice thing. And I really, this is talk from Ian Cooper. For me, it was mind-blowing. He talks about this whole mocking is the root of all evil, and he talked about this in 2017. And in 2007, he already warned about it, that we are going wrong with the whole DI thing. So, as always, Android is a bit late in the game. But in the end, let's go to testivos. Do good things to testing, and good things will happen to you. And thank you for listening.